Okay, to do this problem, we need to know some things about the quadratic formula, maybe. The quadratic equation is one thing you can do. But let's just look at, so in general, solving quadratic equations. It says here, which are solutions. So we want to know how to solve, S-O-L-V-E, quadratic functions or equations. There are some things we can do to solve quadratic equations. One of the things I noticed here with this one, before I do any other examples, is look at the 3, 9, and 12. Your brain should be thinking, well, each one of those has 3's in it. So I could divide out a 3 from that stuff and make it look a little bit easier. And it isn't that hard. So we're just going to if we divide 3 out of the whole thing, it's kind of the opposite of multiplying 3. If I multiplied 3 by plus some different stuff, if I multiplied 3 in, I'm just giving you an example here, there would be 3x squared plus, and if, let's say I had 3 there, plus 9x plus, let's say I had 12 in there, so 36. Okay, 3x squared plus 9x plus 36. That would be if I multiplied a 3 in. Now, if I gave you that and I said, hey, can you divide 3 out of it? Sure. If I put a 3 in the front and then I figured out what was left after I divided a 3 out, well, 3 divided by 3 is just 1. So that's just x squared, or 1x squared. I'm going backwards and showing you dividing something out. If I divided a 3 out of the second one here, I'd have 9 divided by 3, which is just 3. X stays there. And if I 36 divided by 3 would be 12. So we're going to do the same thing here in the beginning, because it begs for it, because I see 3's hiding inside every one of these. So let's copy it over. Sometimes that's always your first step, is to just kind of copy it down. Plus 9x plus 12 equals 0. So that's an equation set equal to 0. Now, if I have to do the same thing to both sides of the equation so I don't upset the balance, because the equation is like a balancing situation. I can't just divide by 3 on the left. I'd have to also divide by 3 on the right. Well, 0 divided by 3, that's easy. That's just still 0. 0 divided by anything is just 0. Okay? But so that doesn't change anything, and that's very convenient. This one, I pull the 3 out. I say I pull it out. I divide it out. I'm left with x squared plus 3x plus 4. Is that right? 4 times 3. So if I multiply that 3 back in there, I can double check my work, right? Now again, I can divide both sides by 3. Why is that convenient? Both sides of the equation by 3. 0 divided by 3 is 0. That's super convenient because 3 divided by 3 is just 1, which makes the 3 go away. That's just a 1. So that's an x squared plus 3x plus 4. Okay? Now when I look at that, it looks a little bit easier. Some of these you can actually just kind of opposite of foiling them. So I can say, well, I know that x times x, remember the FOIL, the first, outer, inner, last. X times x would give me x squared. So I'm working backwards here. This is supposed to be an x squared. So now the other two numbers, remember we did this on one other paper, but positive 4, I'm looking at that last number, the 4. And 4 is 1 times 4, 2 times 2, -1 times -4, and -2 times -2. All of those pairs will equal 4 when I multiply them together. Now what about when I add them? They should give me the 3. I'm looking for the two numbers that are going to go right here, right? And I always look to see what multiplies together to give me +4 and what will add up to 3. Which ones of these pairs just adds up to 3, and those are going to be my answers. And I can see that none of them do. So then I say, well, there is no real solution. If none of them will work, none of them add up to 3, there's a way to kind of tell this a little bit, but it's hard to memorize. So oftentimes, doing what I'm doing here will give you the answer. But these numbers are set up in such a way that there really doesn't exist two numbers that when you multiply them together, they give you 4, and when you add them up, they give you 3. Okay? So this means that there's this thing called imaginary numbers looking here. The I is what's called an imaginary number, and it just means the square root of -1, and that's the definition if you look it up. What the hell is I? Square root of -1. So it's kind of this weird thing in numbers called imaginary numbers. So your answer is going to have imaginary numbers in it, which tells me right now that there's no way it could be that one, because there is no imaginary number in C. Right? There are only imaginary numbers in the other problems. But I still have to be able to do it. So how the hell can I do it? Right? So this is where they seem to be expecting you to know another way besides this way to solve quadratic equations. And it's a very useful thing called the quadratic formula. So I'll give you the quadratic formula. It would take some practice to use it and to get good with it. Right now it probably seems a little bit confusing because I'm kind of throwing a lot of stuff at you, because that's what this test is actually doing, throwing a lot of shit at you, right? All at the same time. So you'll look up this thing called the quadratic formula if you want. And what it says is when you have something like this, ax squared plus bx plus c equal to 0. When you have a quadratic equation that you can find out what your answers, your solutions are for a quadratic equation by doing this formula. So here's the formula. Minus b plus or minus the square root b squared minus 4ac all over 2a. It looks like a nightmare. These are going to be your x answers. There's going to be 2 answers here. And they're not going to, in this instance, they're not going to be real numbers. Okay? Because we're going to have negatives under the square root. Let me help you with it specifically. It might make a tiny bit more sense, right? Again, without doing a lot of these, it's going to seem a little strange. Let me leave that there for now, okay? And let's copy down the original problem, 3x squared plus 9x plus 12 equals 0. My A is 3. My B is 9. My C is, and I could even make it smaller. Wait a minute. Remember that we divided a 3 out of this and we got x squared plus 3x plus 4. Let's use that because it's the same freaking thing, right? It's just smaller numbers. My A now is 1. My B is 3. And my C is 4. A little bit easier to work with these numbers. And we're going to use these numbers into this formula. And then we'll get our 2 answers. So I'm going to just kind of delete that out of there for now. All right. Ready? Minus B. The first thing we have here is we copy down negative and then B. What's my b? 3. So negative 3 plus or minus. I'm just copying that formula down. Square root. What's the b squared? B is 3. What's 3 squared? 9. Minus 4 times a times c. What's a and c? A is 1. C is 4. So I already have the 1, which I don't even need to write it, to be honest with you, and the 4. So that's actually going to be 4 times 1 times 4, which is 16, right? All over 2a. My a is 1, right? 2 times 1, just 2. Okay? So that is copying it over, because this is often what we do, this boring step of just copying everything over again, plus or minus, and I'm copying the square root, and I've got 9, be careful, you have to do what's under the square root first. 9 minus 16, we said that was 16, and all of that is over 2, or 2 times 1. Copy it over one more time. Negative 3 plus or minus the square root of a negative number, because 9 take away 16 gives you something negative. So that's 7, negative 7, right? Negative 7. And then we have the 2. So our answers are gonna, well, first of all, when you got a negative number under the square root, look here, right here, negative number under a square root, negative 1 under the square root is an I. That's a negative 1 under a square root. If you had a negative 7 under a square root, that's a 7i. Okay? Let's see. Square root of negative 1. I times the square root of 7. Okay, so let me write it over. So negative 3 plus or minus I times the square root of 7, and it's all over 2. I think we've got our answer, which would be negative 3 halves. We could put the 2 with both of them, like negative 3 over 2 plus or minus I times the square root of 7 over 2, right? Something like that. Over 2. There we go. Yep. So that's my answer A. Is that right? I'm sure you have 1,000 questions. I'd like you to be able to ask me. Maybe we can meet again sometime when we can coordinate a time. Okay. Good luck, man. Hang in there. I know it's frustrating when there's so many different things.